So to carry on with electrolysis of aqueous solutions, electrolysis of water. Now pure water cannot be electrolyzed, or electrolysis, if it is done, it will take ages before a cylinder of hydrogen or oxygen is produced. An obvious reason is because water ionizes to a very little extent, negligible extent. It breaks up to H positive and OH negative ion and reverse back. So stuck to the state of dynamic equilibrium. Easy to remember, water has very poor ionization. But when you add a little amount of concentrated sulfuric acid, ionization is prompt, speedy, and when you switch on the DC current, you will find out the electrolysis is taking place quickly, and 2 volumes of hydrogen and 1 volume of oxygen is the ratio at the pipes linked with cathode and anode. You will find out because when water is electrolyzed, end of the day you will find out always there is 2 volume of hydrogen and 1 of oxygen. Water when electrolyzed, 2 volume of hydrogen and 1 of oxygen. It's the ratio, it's the standard ratio. I said pure water cannot be electrolyzed, or little electrolysis is done. That's very slow process, but when we add sulfuric acid and electrolysis is done, then it completely ionizes, and a speedy process it is. Rather, this can be a method for the production of pure hydrogen and oxygen. The only problem can be a very high voltage use for the production of hydrogen and oxygen. This may be an expensive method, but depends on the area or the hydroelectric power it is used. We can get pure oxygen and hydrogen by this method. Sulfuric acid, when it is added in a little amount, concentrated one, it makes this electrolyte as a sort of dilute sulfuric acid. So electrolysis of water sometime can be asked as electrolysis of dilute sulfuric acid. Meaning when he asks you to show the electrolysis of water, you have to mention that a little amount of sulfuric acid concentrated is essential in the electrolytic cell, each and every cell. Or you can say it is the electrolysis of basically the dilute sulfuric acid. And sulfuric acid ionizes to provide hydrogen ions, but the sulfate ions. And the sulfate ions got the key because they compete with hydroxyl ions because they are at the top. So hydroxyl ion discharge in preference, and when hydroxyl ions are constantly being discharged, because of this competition, dynamic equilibrium shifts to the right side. As they are moving off, then the dynamic equilibrium disturbed. Water has to ionize to keep its dynamic equilibrium intact. So in the process, basically, they discharges, and water basically completely ionizes. Maybe a difficult thing to understand, easy. Sulfuric acid is added to speed up the ionization process. Okay, sulfate ion stays back, they have no discharge mechanism, they only push hydroxyl ion to discharge. So at cathode we have only one variety of ions, H positive ion, because H positive ion, if they are coming from sulfuric acid or water, they are same. And at cathode, no competition, hydrogen ions will accept electron and turn to hydrogen atoms, which later on turn to hydrogen gas, diatomic, and we balance the equation. 2 hydrogen ion accepts 2 electron, turn to H2. But since when we look at the hydroxyl ion equation, it has only one discharge mechanism. It breaks up to water, oxygen, and the electrons, 4 electrons. You need to memorize this equation. So you will find out when there are 4 electrons there, we multiply this equation with 2 to make this part as 4 electrons. Because I said when they discharges, they should discharge like, first basic equation can be this, because it is diatomic. But since there are 4 electrons there, we multiply this equation with 2. That makes things here 4 electrons. Sometime if he asks you to write down an overall equation, if he asks, somewhere you are asked, then overall equation mean we cancel out things same on both sides, electrons only in this case. 4 electron with 4 electron, they are cancelled. So left behind we have 4 hydrogen ions, 4 hydroxyl ion slash or plus arrow. Left behind on the product side is 2 hydrogen, 2 water molecules, and basically 1 oxygen. Anyhow, this is the overall equation. For us, chemical equation may be important because sometime he asks you to basically find out the volume of oxygen produced or hydrogen produced. In that case, he'll mention the mass of water used. So we can use the moles formula. So for that we need a chemical equation, and chemical equation from the concept that water breaks up to hydrogen and oxygen, and then we balance two water molecules, 2H2N. If he asks you why there are always two volumes of hydrogen and one of oxygen, he will suggest because water, when electrolyzed, the chemical equation, the chemical reaction basically is electrodecomposition, that shows that it follows a ratio of two volumes of hydrogen and one of oxygen. I stress at the fact that when he asks you why hydrogen is in 2 volume ratio and oxygen is 1, look at the volume ratio, 2 volume, 1 volume. A simple MCQ may ask you that 20 dm cube of hydrogen is produced in electrolysis of water. What will you expect the volume of oxygen? And you know that it is ratio 2:1. It means 20 dm cube, the ratio of oxygen should be 10 dm cube. If it is 100 dm cube, then it should be 50. If it is 200 dm cube oxygen, then hydrogen should be, of course, twice, 400 dm cube. So it means water when electrolyzed, the rule of chemical equation shows that there are 2 volumes of hydrogen and 1 of oxygen produced. That is why electrolysis of water is done. If you ask a mole question, even then we should be given the mass of water used. So we can basically make a mole ratio box, and we can find out that how much water is used and how much hydrogen is produced, or how much water is used and how much oxygen is produced. So electrolysis of water may be done at a place where hydroelectric power, a cheaper electric power is there. It will provide us the best pure hydrogen and oxygen, but key is a little amount of sulfuric acid will prompt the ionization, and you write cathodic equation and anodic. Cathodic as always showing gain of electron, and anodic as always showing loss of electron. Hydrogen ion will accept electron, they are cations at cathode, and hydroxyl ions will lose electron at anode. We have the products hydrogen gas and oxygen gas. Hydrogen has huge uses in ammonia industry and other industries, especially the oil to ghee, and oxygen gas is basically used by deep sea divers, high altitude climbers, in the hospitals, and in oxyacetylene flame to weld things, and plenty of other places. So this is electrolysis of water.